All right, I think we have a quorum. So thank you everybody for joining today. I would like to extend my good morning, good afternoon, good evening to everybody. In our session today, we're covering application portability and collaboration across any Kubernetes, and we will showcase that on our Weave Kubernetes platform. Paul, would you flip over? Couple of housekeeping items. Please notice that you are in listen-only mode. If you have questions, please use the Q&A window for those, and we will go through those towards the end of the session. And then Paul, next, please. So I would like to introduce Paul today. We have Paul Curtis, Principal Solutions Architect here at WeaveWorks. A quick bio on him. If you have had if you attended one of our previous sessions, you probably have met Paul before with us. And then I will hand it over to Paul, and he will take us through the next hour. Thank you very much.
Good afternoon, good evening, good morning. So I'm Paul Curtis, as he said, Principal Solutions Architect. So I'm going to talk a couple of things about GitOps in general. We're going to go through the WKP 2.4 platform with a focus on Team Workspaces and how that enables application portability and why GitOps makes this really simple. WeaveWorks is a company, just so that you know, we do a lot of open source work. You've probably seen our tools. So Flux, Flagger, Scope, WeaveNet, there's actually a lot of them. We're fairly large Kubernetes contributors as well. But we also provide services. So we do a lot of training and a lot of design with companies to figure out which tools to use in Kubernetes. And that seems to be a lot of people's decisions now. Is there's so many out there. What do I use and how do I get what I need? And the last thing is that we have product as well. So we provide a packaged Kubernetes platform, the Weave Kubernetes Platform, which we're going to look at today, which comes with all of the product as well as support for it. So 24/7 support. And that comes in various different flavors. So all that being said, let's touch on GitOps in general very quickly. So there was a survey recently done in the last year that talked about the things that teams are trying to achieve. And if you look at this picture, look at the green boxes and the blue boxes. And the study URL is there. But basically, they're looking at how to cut down the lead time for developers. In other words, the amount of time it takes any iteration of a development cycle through CI. And then also how fast they can do deployments. So one of the things that becomes apparent is that if they finished developing something, they want to test it and deploy it and integrate it as quickly as possible. The other part of it on the software development side talks about change fail. And the thing is that how fast can I fix something? Okay. And the key one for many DevOps teams, also operators as well, but certainly the management of any big operation, is the mean time to recover. It's like, how fast can I get back to a full running state when I have a problem? So we have a customer, which is NatWest, and their Metal section, which is their online banking. And they were a big Kubernetes user, very large Kubernetes user. And they came to us and we implemented with them, alongside them, GitOps, the GitOps methodology. And I'm not going to go through everything on this slide, but the key thing to realize is that the two key metrics from the last slide, mean time to failure, the average in the industry in the Kubernetes world was about an hour. Metal got it down to 20 minutes, and that includes spinning up the cluster from scratch. The other thing that they saw was deployment frequency went up because the operations team didn't have to be involved in deployment if you allowed the developers to go ahead and use GitOps to test their images, i.e. deploy them directly. And that kind of predicated a time saving as well, because if I don't have to sit and wait for me to test in an integration environment, it means that I have more time to code. So they kind of build on each other as you go through it. and metal, these are their numbers. We didn't come up with these. They actually came back to us with what they found after implementing GitOps. But the key thing on this one is GitOps doesn't just cover the applications. It can cover the clusters themselves. It can cover fleets of clusters. It can cover the configurations of those clusters. And today we're going to talk about Weave Kubernetes Platform 2.4, which we're going to specifically focus on the applications, but you're also going to see the configuration as well. So what is the Weave Kubernetes Platform? It is a methodology using design best practices here and a design pattern that we have found our customers use over and over and over again to first bootstrap and deploy Kubernetes if you want to, or if you already have the cluster, how to have a cluster components or a profile or a baseline template for what the cluster has to have, and then how to build out multi-tenant application stacks. And so when you look at it as a diagram like this, that blue box in the middle is what I'm talking about. So the platform includes all of our open source tooling, okay? It also includes 24/7 support for our tooling and pretty much any Kubernetes resource you want to put in there. But there's a management UI and there's a couple of design patterns that we have coded in so that you can actually take benefit of what we've seen our customers do. And the one I'm going to focus on today is Team Workspaces specifically. And if you'll hang on one second, I'm going to get rid of my notifications. Thank you. Sorry about that. So Team Workspaces is a methodology and a design pattern that says we're going to use Kubernetes namespaces, but we're going to make it automated, we're going to make it declarative, and we're going to put in a standard set of controls. And that includes things like RBAC and roles and network policy and things like that, so that you can actually build a true tenant in there with one single declaration. And we'll take a look at what that looks like. The other thing is that as with all Weaveworks products and the things that we work with and distribute, we use GitOps for everything. So the Team Workspaces are GitOps enabled because they are declarative, and the cluster's configuration itself is also declarative. And so I'll show you that during the demo. You can actually see what it looks like. But the idea on Team Workspaces is pretty straightforward. In order to enable developers and DevOps teams to work faster, you basically want to give them the ability to deploy. Okay, so what Team Workspaces does is it creates a workspace on a Kubernetes cluster that has appropriate security controls, as well as attaching that one namespace to a specific Git repo. And so the manifests or Helm charts or whatever is put into that particular team's Git repo will be deployed into their workspace. Now, obviously, you don't want anything to go in there, and also you want to make sure it's restricted to that workspace. So part of what Team Workspaces does in WKP 2.4 is to automatically put those controls in place. So I'm going to jump over to a demo right now. So if you give me a second, let me switch screens. So I can find the right one, and it's this one. So Weave Kubernetes Platform, by its nature, is agnostic to the Kubernetes it runs on. So this one happens to be, I believe this is in EKS, but this would work exactly the same way in Azure or GKE or in your own Kubernetes cluster, whether that be something you've done or whether you're using a different distribution. It works pretty much all Kubernetes platforms that are out there. So we talked about configuration for the cluster. So I'm going to touch on that very quickly. We define in our design pattern something called cluster components. This is a baseline configuration of the cluster. Now, if you scroll down, you're going to see the usual stuff in here. So our default package, if you just installed WKP out of the box, you're going to get Prometheus all configured. You're going to get Grafana with a set of dashboards that you can work with. Okay, you're going to get Weave Scope, so you can visualize your cluster. So the kinds of things that you would expect to have in all of your cluster management tools, things that you would install continuously and on every cluster, we've already prepackaged and pre-configured. So this makes it a very simple install. Now, as I said, you can have WKP bootstrap Kubernetes. Okay, so actually provision and then bootstrap Kubernetes, or you can apply it to a managed service like EKS or AKS, GKE, or any other Kubernetes cluster that you have. So you can bring your own cluster to this. But the key thing to understand is that there's nothing in this list of cluster components that is not contained in a Git repo. Yep, let me make this a little bigger. So if you go in, I can actually see and alter and change the baseline configuration purely by going in here and altering these manifests or Helm charts. We use JK in some cases, so there's a lot of different things that you can put in here. But I want you to take note of one thing. When we talk about Team Workspaces, they are declared the same way that everything else in Kubernetes is declared. And in fact, in our cluster, they are declared the same way that a cluster component is declared. So I'll come back to this when we get to a little farther with Team Workspaces. So what is a workspace? So let's start there. So workspace, as I said, is fundamentally a tenant in this WKP cluster. We take advantage of Kubernetes built-in namespaces, and pretty much that's kind of a standard practice for most application stacks. But in order to configure that consistently every single time for every different potential tenant you have, we've made it very simple by making these declarative. We've also made it even simpler by tying it to the Git repos themselves. So this one happens to be tied to, I believe it's GitHub. So if I have GitHub organizations, I can just pick the GitHub organization that I am a member of, and we'll talk about authorization in a second. And I can just go down and say, okay, I need for this team, I need a workspace for him. And I'll just go ahead and create it. What's happening in background that you don't see, and I'll show you in a second, is that we've sent that declaration into WKP. There is Flux running there. So that change is written to a Git repo, right? So we will go and look at that. So that manifest, that actual Team Workspace is now defined here, and here is its declaration. And as you can see, it's pretty straightforward. A couple of things to note. The Git provider and the repository, if you have these already set up, you can actually declare Team Workspaces declaratively in WKP without having to use the UI, because I just put a declaration like this into that Git repo for the cluster, and it will create it. And we'll talk about how that actually gets done. There's another thing to note here as well. There's a role. So part of what the controller does is it creates a very specific namespace scoped administrative role. And we'll take a look at that in a second. But you have an enormous amount of control here about who has the right to do things to this workspace, who can apply things, right? Most GitOps enabled clusters, you don't give out kubeconfig files. Every interaction that a user has in order to deploy something into these clusters is done through Git. So I can open up the Team Workspace Git, and here it is. And it's very nice. We give you little instructions if it doesn't exist on how to do it. You also have the ability to do a couple of other things. Because we have namespace scoped them, and it's based on what teams you are, what part of the organization you are in GitHub, will determine whether you have access to this or not. And you can actually see it. So you can go in and query the workspace in a number of different ways to determine what your access is and what abilities your team or any other teams have to your workspace. So when you step back and you look at how Git organizations work, you can begin to see that you could have teams where it might be one workspace to one team, but you also may have occasions where you have two teams that need to work on the applications that exist in one workspace. And by setting up the team and then putting the members into it, and then making two teams attached to a particular workspace, it means that now you have the ability to actually build out who can deploy into each one of these tenant namespaces. So this is a very, very powerful thing. WKP, the platform, and the way we deliver it out of the box gives you a fairly simplistic mechanism. So it's typically one workspace to one Git repo to one team, but it doesn't necessarily have to be that way. And as I said, when you look at the UI, you can see that we give you the option to create the simplest use case here. Now, there is no reason that I can't go into this manifest and alter it and commit it, and the controller will make those changes on the fly. So you don't even have to delete the namespace. I can actually point it to a different repo. I could change the team membership here. Okay, you can see right now, for those who are YAML aware, that's an array. So you have a list here. You can put multiple teams. Also, you'll notice that the role, which is created, that's namespace scoped, doesn't necessarily have to be the one that the controller creates for you. So this, in combination with GitOps in general, gives you a easy, simple way to define out how those namespaces work. So I'm going to jump into scope for a second, and I'm going to pick one of the namespaces. I'm trying to remember which one has something in it. So that's all of them. Nope, that one doesn't. This one does. All right, so in this particular case, there happens to be only one pod running in here. So every application, and you go in and you look at run as, is actually run as that role. So I'm going to switch over and explore the team workspace from a very technical point of view right now. I don't see any questions yet. So let me just jump over and we'll take a look at what this looks like for real from the Kubernetes point of view. Okay, so I'm going to use K9S for this just because it presents very nicely. This is the cluster you just saw. So I'm going to refresh the namespaces. So you can see here are the namespaces that are created. So when I go into, and I'm going to pick one that has an application in it, I can see, here's that pod that we saw in scope. But what you also see here is here's the role binding that gets created for it. So it's already there. And if I take a look at what that is, that role, which is namespace scope, pretty much can do anything that it needs to do in that namespace. So for those who have done RBAC, you look at this list and you realize that that's pretty much all of them. Okay, you'll notice it's not restricted by API group either. So that gives you a general idea of how we do this. And also because that is an account, it means that you can actually get, if you want to, a kube config that is specific to that role and that service account so that you can provide it to developers who don't want to use Git or want to use kube control apply or need to do some other things in their workspace. You can give them that capability. But for the most part, we don't. So a couple of other quickies. How does this work? So let's go down to the workspaces namespace. What you see here is Flux version 2, the GitOps toolkit. So the most of the work is being done very, very specifically by Flux version 2. Because the GitOps toolkit, the newer version of Flux that was released last summer, this is when it began real true development. It allows you to attach any source repository to any target destination. So for example, the namespace is the target, the source repo is something that we configured on your behalf. So we do include all of the normal Flux version 2. So the source controller is here, as you can see, notification controller. So you can provide those back and forth, customize as a part of this. But what is actually doing the work here is the workspace controller. So when you create a Team Workspace manifest or alter one, it is the workspace's controller that is checking that change and applying it to the appropriate manifests for Flux to execute. This also means that everything in this cluster is 100% GitOps, including the cluster itself. So everything that's built into here and everything that we've added to it is all manifest driven. It's all driven from Git, which means two very critical things. The first one is, since everything is declarative and it is in a Git repository, it is not necessary to pass out the kube config, because the authorization to change any deployment, any workspace, any application running in any workspace is all authorized through the source code repository, Git itself. So if you organize your teams and organize your workspaces, you can, as I said earlier, can have one team to one workspace, which is the simple case. But you can have any variation of that, and you can do it declaratively. So when I go back and look at, for example, let me just step up to the actual cluster itself. If I go into and look at the workspaces, any changes in here, I'm going to know immediately because I can go in and look at the Git history. So you will see that these were the UI. If I made a change to that, and you can see I did down here, I deleted some things. Okay, but it's all logged and it's all verified. So everything in this cluster is automatically audited at every level. The second thing with GitOps and Team Workspaces and the applications that run in them is that they're monitored constantly. If there is a divergence, if what you declared in your manifest is not running in the cluster, you'll be alerted immediately. So that idea of config drift, where the cluster doesn't match the configuration you think it's supposed to, really can't happen in GitOps because it's constantly checked against the declarations. And if it needs to fix that, it will obviously make the cluster match the declaration. But also in the application sense, it means that if the application crashes or somebody even deletes the pod, it will be brought back automatically. So if somebody did something not good, like if I went into here and did something, kind of bad and said, yep, let's, delete the pod, you're going to find out very quickly that even if I took the deployment out, it would restart it. So if I deleted the deployment, it would come back in a certain amount of time. So the application stack's recovery time is as fast as it is reconciled between the Git repo and what is actually running in the cluster. Okay, so I'm going to switch back for a second. Let me go over to back to our UI for a minute. I think that should be this one. Okay, so as I said, you were looking at the other screen, but everything that gets changed here gets changed 100% in Git. So even when I do things through the UI, it's all audited. And I can actually go in and look at Git diff. And that was where I created that namespace via the UI. So it becomes very, very simple to not only audit it, but to know exactly what's running. So everything is audited in the same way. So when you look at the cluster from in its entirety, you begin to see that it becomes very simple for you to guarantee that what you've declared in one or more Git repositories is there. Now, the application stack, and I see a question, I'll get to this, get to it in a second. The application stack, when you look at a workspace, right, you'll notice that in this user interface, we don't really define the applications themselves. Okay, what we're doing here is we're defining where the workspace gets that application information from. And in this particular case, they happen to be in the same Git repos. But if I go in and look at the organization and actually say, show me the whole organization, right? If I scan down, I'll see my workspaces, right? So they're here. And they look just like standard deployments. Authorization says the development team that's using this demo workspace are the only people who can write to this repo. So that team or a group of people or even individual member, if they have write access here, they can change these deployments. So if I delete something from here, it will be deleted from the cluster. Okay, so I'm going to stop there for a second and we'll go over to 2 questions. So the first question has to do with the Rancher and the Rancher UI. So for the most part, the information that the user interface provides you here is similar to what you would see from most other Kubernetes distributions, I guess is the way to put that. The difference here is that the management of the clusters themselves, the actual underlying bootstrapping of Kubernetes is not a single point of failure, right? Because it's managed from Git. So the definition of this cluster, okay, what got installed here, this part, and plus the cluster's configuration itself, which down here, here's the 3 nodes. Yes, and yes, this is EKS, is actually defined in Git as well. So you can GitOps enable the whole process. Now, many companies have already done the underlying infrastructure in Kubernetes Bootstrap with other tools, Rancher being one of them, but other tools like Ansible, okay, or Terraform seems to be very common. Some have done it just manually. They don't change their clusters that often. Those all will work with the WKP platform because all of this, the cluster components, is above the Kubernetes level. The major difference between the way we approach provisioning and bootstrapping Kubernetes from pretty much everywhere else is that we use the cluster API to do it. So in that sense, Weaveworks as a company, we don't actually develop the different providers, of which there are now 12 or 13. We use the cluster API to drive those providers to do the provisioning. So this EKS cluster and our this EKS cluster through WKP was done with CAPI. Okay. And if you noticed, I don't know if anybody noticed that rather odd looking thing, but I'll go back and show it to you again. Let me just go in here for a second. You'll see in here something very interesting. Yep. There is an EKS controller. So there are a lot of things that are built in that we're providing. You'll also notice that because this is an EKS cluster, we made a couple of default things for you. For example, we give you the ALB. So we give you an ingress controller by default. And in fact, that's how I'm accessing this UI. You'll also see here's Flux. And if you go a little farther down, you'll see here's the workspace controllers at the bottom. So our approach is always get oriented. Reason that the biggest single difference there is two. One, Flux and these tools reconcile constantly. So even in the case of clusters and fleets of clusters, because CAPI, the cluster API, is declarative, it means that the CAPI interface is going to keep those up and running because Flux is going to make sure that what is running, what CAPI reports as up, is actually matches the clusters you've defined. If you go to the application level, the same thing is true, right? What we are comparing is what you've declared in Git, and we do it via Git clone, actually, and we enumerate the Kubernetes API. So we actually diff the two of them constantly. That's how we get around the infrastructure as code, because it's always constantly reconciled. Most of the other tools that are out there that do provisioning are one way. Okay, unless you use status checking in Terraform or you actually use Ansible Tower, you're not going to get that feedback. And then again, you're not necessarily going to know why it failed. Whereas in the GitOps methodology, I can be very precise and tell you exactly why it failed, because I can go look at the logs and Flux will tell me why it could not do that. The second question is, for rollback to a previous version, would you recommend using the declarative method? Oh, yes, absolutely. Absolutely. Because rolling back in the GitOps methodology is pretty straightforward. Is what do you end up doing? You either recommit the correction. In other words, let's say you put in the wrong image tag version, okay? You go back and you actually just either correct it by modifying the file, committing it, and pushing it, or you roll back the commit ID of the head of whatever branch you're monitoring. Both of those work. So in its most simple form, because Git has kept track of a declared cluster, you will be able to say, this is a working cluster at this commit ID. And if somebody changes something or makes, alters something, or if something breaks, or you deploy something new or an upgrade and it fails, it means that I can go back to a known working state for the cluster application stack. Now, I always caveat this so that people pay attention to this. Obviously, GitOps and Kubernetes don't know about persistent data. So when you begin to think about rollback things, Santosh, you also have to consider how you deal with rolling back persistent data. Right, and I'll give you a good example, a schema change between versions on a database. Right, well, is it back? If it's not backwardly compatible or forwardly compatible, you might have to do some things there. But also data sets, just standard data. Okay, make sure if you roll back the application, is it going to see a different data set and break? Well, you got to be a little careful. So you have to kind of pay attention to that. So I'm going to switch back over to some pictures. Oh, wait. Okay. I'm going to switch back over to some pictures for a second because I want to talk about portability. Right. So we showed you this diagram of Team Workspaces. Right. This is a single cluster. right? But we also said that since the team workspace is declarative, it doesn't really matter how many clusters it's declared in. So when you go to the next step, we'll skip by the demo, right? We're here, but now what's to say I can't have two clusters with the same workspace declared pointing to the same Git repo? Nothing. There is nothing. So application portability becomes something very, very simple. If we assume that we've configured and bootstrapped our Kubernetes clusters to provide the same services no matter where they are running, whether they are running on-premise or on, let's say, EKS or GKE, if we're providing the application stack the same set of services, I'll bet they may be different underneath, but to the application, they see the services the same way. It means that spinning up the service on another cluster is merely either adding this team workspace manifest to that cluster is probably the fastest way to do it. You can also use the UI in WKP to do this because you can create on a different cluster pointing to a workspace that already exists, right? If it doesn't exist, it gets created. If it does exist, it just uses it. So if I delete the workspace on my cluster, I don't necessarily delete the Git repo that's behind it. So you can get a lot of combinations on how to make that work. Excuse me. So when we now look at how we lay out clusters and how we lay out application stacks, it now becomes, where do I want them, right? So let's take a total, I'm going to turn this view a little bit. I've been talking about application stacks. That's one approach. We have customers who use workspaces for stages of application development. So they'll have a dev workspace, an integration test workspace, a QA workspace, and a production workspace. And the way they do that is they actually have the same repo, either using different directories or different branches. So they can do things like do pull requests between the stages, right? Because it's Git, it's source code. If you begin to think about how you deploy applications, the same way you think about how you do a software release, tagging, pull requests, merge review, merge, you begin to see that any process that you want to come up with for gating or putting in gates into the GitOps process becomes a matter of really using the same ones you already do in the software world, right? So my background is a developer. So for me, having production be the head of the main branch, and then QA being a QA branch, and dev being a dev branch, or as forks of those repos, it becomes very, very simple to come up with very clever and creative ways to do the promotion of applications between those stages. And team workspaces can be used that way. We're not restricting you from doing that. In fact, we have a fairly large customer we just did where their dev and integration testing is all in one cluster. Their QA cluster, where they do their staging testing, scale testing, is actually a cluster that's brought up and down. In other words, it doesn't run all the time. Why? Because for them to recreate the production environment, all they got to do is spin up the cluster and point it to a Git repo, and Flux will install all the baseline things and the application stacks. So they can bring up a staging cluster even on EKS with the amount of time that EKS takes in about 10 minutes, right? They can run a staging test that takes 12 hours. And then when they're done, either pass or fail, they can shut it back down because they know they can bring it back within 10 minutes, right? The production cluster in their world is actually a specific Git repo that only a small group of people have write access to. The way things get promoted is they forked the production Git repository for the developers and the integration testers to use, and they do pull requests. And then when they're ready to do a deployment, it goes through a merge review, and then it is merged. And that's how they do their releases. And then they tag them. So they use Git tags just as a way to know the last known working configuration. So they can say that, on this date, we tagged version 3, and we know the version 3 runs, right? So if I ever have to go back, I don't have to roll back all the commit IDs. I don't have to think about it. I just can go back to a tag. So the same things you use in software development and the same kinds of processes and thought processes you do become the same ones you use in GitOps, which kind of brings us to the last picture, which is if you think about the CI process and you realize that the only difference between CI for software development and CI for software deployment is what the code is, right? Software release, I'm writing an application. Deployment release, I'm writing manifests or Helm charts, okay? Or building customized templates. If you begin to think about it that way, it becomes very simple. The tools that the WKP platform gives you that go along with this is that Team Workspaces, we're just doing a lot of work for you. We're giving you an easy way to manage multiple application stacks or multiple application stages in a single cluster declaratively, right? And yes, you could probably do all this on your own, okay, and figure it out. But it is so much easier to let the controller do it because it's going to be consistent every single time, right? You're always going to get the roles. You're always going to get the namespace. You're always going to get the same RBAC put into place and always going to get the same network policy, et cetera, et cetera, et cetera. So you don't ever have to really worry about it. And because WKP goes the next step where it has a baseline configuration and an application set configurations, okay, so how they are deployed are vastly different. There's a clear, bright line between operations, i.e. the teams that manage the infrastructure and the services that that infrastructure provide, versus the dev teams, which are doing the application stacks. So you really can make that a clear delineation. Now, of course, we'll make another comment, which is you don't have to do it that way, but you can. Again, we keep coming back to the GitOps methodology, and WKP as a platform has some design patterns, but it is not very opinionated. You can use those design patterns any way you want. And I've already given you 2 different basic ones that we see our customers do a lot. We also see a third one. We see customers use WKP where all of the applications are in the cluster baseline. And you'd say, why would you ever do that? And I say, think about Kubeflow, okay, which is the machine learning framework. The end users don't interact with application stacks, they interact with Kubeflow. So you're going to want a machine learning cluster to have Kubeflow be installed as part of its baseline configuration. That would be true of other frameworks like that, but that one's the easiest to demonstrate. So that kind of gives you a general idea of some of the design patterns and where Team Workspaces comes into play. And I'm going to wrap up with just some really quick points. We've talked about all of this, so I don't really need to go through these, but there's a couple of things that I want to point out at the very end. One of the biggest headaches in managing Kubernetes, especially across multiple clouds, is that you get into a situation where each cloud vendor, public and or private, has a different way to do authorization and authentication, right? And so if you're using GitOps, you can, if you choose, make the deployment authorizations work through the Git repositories authorization and authentication schemes, rather than having to figure it out on a cluster by cluster or cloud provider by cloud provider basis. Now, to some people, that seems very simplistic. But when you think about it for a second, right, the ability for a cluster user to match the GitHub user that matches the team who deployed the application actually makes a lot of sense. Okay. Now, in some cases, some companies have implemented that through their centralized authorization mechanism, like Active Directory or LDAP, things like that. And that gets pushed into the cloud providers. Well, it also would get pushed into GitHub or GitLab or whatever Git repository you're using as well. So this makes the security, authentication, and authorization policy pretty much consistent across everything. And it also will make it go faster for your InfoSec team, because guess what? They've probably vetted GitHub or GitLab already. So they know how it works. It's already passed muster. If you turn to them and say, these tools do nothing but use authorization from Git, pretty much they're all done. So you've removed a barrier. Whereas if you went with a third-party tool, to go back to the other tools that are out there that do this kind of thing, if I bring in a third-party tool, that third-party tool has to be vetted for security, right? And there's a whole set of questions that are going to come out around that. Whereas in order to do this with WKP, you only have to vet the controller. And the source code's public, so they can go in and look at it. We can tell them exactly how it works, right? And what they will realize is that between the use of deploy keys, okay, and personalized access tokens, depending on how you are authorizing, means that that agent that's running in the cluster actually is an identifiable user. Right? So the security issue kind of gets handled by standard policy and best practices in Git, rather than having to figure them out every time in every Kubernetes cluster on every different cloud provider. So I bring that one out because we find that can be an extraordinarily easy thing to discuss with an InfoSec team when bringing in a new installation mechanism or a new bootstrapping mechanism. You don't have to come up with how does Ansible do it. You don't have to figure out Terraform users, right? I don't have to tie it to IAM, let's say, in Amazon. Because if you're any kind of shop that's using Git, you've already done that. So it takes that out of the loop and it just vastly disappears. The last thing is just a quick roadmap to where we find our customers going with WKP. Right. So a lot of what we do as a company, Weaveworks, is educate. We go in and help people design and architect. So a lot of the examples that you heard today on this webinar are coming from our customers, right? They figured out different ways to do things, and they've come up with some pretty clever ways to use GitOps, and some surprising ways as well. The second thing is that we're not a consulting shop in the way that you think of. We don't come in and we don't live at your site forever and ever and ever. Our goal is to come in and to educate and enable your team, figure out what you need to do, show you how to do it. And since I'll guarantee you there's a Git expert somewhere in your company, you probably have most of that enablement done, right? Helping you get through some of the other things that you have to do, like security audits and things like that. Certainly any compliance questions, regulatory questions, we help do that with customers on behalf of the tools that we have both in our products and in the open source community. Which brings us to the last two things, which is the Weave Kubernetes platform by itself and Team Workspaces was born out of customer experience. So these are design patterns we have implemented. Back in the old days, we used to do it manually, but we've seen our customers do this over and over and over again. And these are customers who range from the very largest financial institutions down to, the web shop that's running, a web service and everything in between. GitOps doesn't need scale. GitOps doesn't need a lot of money to do it. You can enable this and gain support for your Kubernetes installations by using the platform. As I mentioned, you get support with that as well. So if you're using Istio, you can call us and we'll help you fix that. But that's part of what the platform brings. And as you go along, you can see that there's a whole stack of apps that we built. So you see them, you see Flux, you see Scope, you see Flagger, you see the GitOps Toolkit are the primary ones that everybody recognizes Weave for. They recognize WeaveNet, okay, which is an open source CNI that we built. So we're very big into the community, and most of the applications that we built on WKP basically come from our open source contributions. And I'm going to go to questions and just take a quick look over and see if there's anything. I can only see the Q&A, Sonia, so I can't see the chat.
Yeah, there was nothing in the chat. Please feel free to enter something, folks, either on the chat. I can monitor that, or ideally in the Q&A. You can just give it a second. I also did post a couple of resources on here. So there is a in-depth blog post actually on the Workspaces feature that talks about quite a few things that Paul mentioned as well. So I posted that, and it's on our blog. And then, yeah, if you want to get in touch for another demo on WKP or in-depth questions, please schedule something with us. We also offer actually GitOps assessments for folks if they're interested in getting a GitOps methodology into their current work environment, have a chat about that. We'd be happy to get in touch and work with you on that as well.
So I'll add one other thing is that I do a lot of the pre-sales. So understand that the Weave Kubernetes platform that you saw includes the management UI and the tooling. We have offerings that don't include all the tooling as well. So when you look at if I have things that I've already built or processes already in place, it may be that we can support you and your Kubernetes installations with the open source tools and all of the controllers that go with it, rather than just the whole package as a complete item. And also, I keep stressing this, keep in mind that when we talk about support, we're not talking just about WKP. There is a list of Kubernetes components and resources that we will include in our support package by default when you use the platform. And so that includes things like CNIs and CSIs and service meshes, configuration help, things like that. Prometheus, Grafana, the standard set of tools that you would see. And remember, our customer base is huge. So we've seen all of the other monitoring tools and watch tools and performance tools and all of those things. We've seen pretty much all of them at least once, if not more than once. So the support is part of that and is part of what you get when you work with us and the platform together. And on that, I don't see any other questions. So I guess
that's it. Thank you so much, Paul. Really appreciate that. And again, if somebody has any questions, reach out to us. We're also on the community Slack available. That's another place to find us. And then I'll be happy to follow up with an email on the recording and the deck. Thanks again. Have a great day, everybody. Bye-bye.
Bye.